Hi, I'm DJ Ware. On this episode of the CyberGizmo, I'm going to go back to a video I made about 7 months ago now and take a look at the next step in ZFS on Linux right after this. So just to let you know, I am planning to do a ZFS on Linux part 3, but for today I thought, well, let's take the next logical step. We've talked about snapshots on the previous video just a bit, but I want to go in a little bit more depth on it and then talk about clones and when you might want to use those and when you might not want to use those. And then we'll talk about discretionary access controls and ACLs. And I do want to touch on replication today, although replication is really an advanced topic in ZFS. But I will also put some links down below in the comments on on several books actually on ZFS that may help you in understanding replication. It is a complicated subject. So let's get started and dive in a little bit. So that's what I want to cover today is those three things, and then we'll touch a little bit on replication. The third video, my plans is to talk about sharing, setting up NFS and Samba or CIFS, and also to look at creating zvols, which then can be used to create iSCSI targets. So that's really the large section of the power of ZFS. Those three things allows you to share it out with other clients, of course. So snapshots. So I've talked about those in the last video briefly at the end, but it's one of two of the most powerful features in ZFS. Snapshots, of course, freeze the system contents at a certain point in time. The creation of snapshots is very fast because it's not copying any data. It's just creating a point in time. But the thing I did not tell you last time is that snapshots, once they're created, the snapshot itself is read-only. Now, that doesn't mean that your file system under it isn't read-only. It just means that the snapshot is read-only. So what's it for? It's for long-running jobs that require a static file system. So, for example, maybe I'm doing a backup job and it's going to take hours to do this thing, and I have applications that are running that I don't want to take down that are writing to the file system. Well, I can create a snapshot, and that will freeze the file system and allow me to start that backup job and perform the backup against that snapshot. Even though it's going to take hours to complete, as far as the backup's concerned, it's looking at a file system state that is immutable. It's not changeable. It's useful for backing up applications like database. Well, database servers have special needs, so I don't really mean to say that I'm recommending you snapshot a database. No, not at all. The problem with databases is that they don't really pay much attention to what Linux is doing. They keep track of everything themselves inside the database. And if you were to restore a database that had been running, you run the risk that the date and timestamp pointers that are in each of the tables won't match. And I know that in the case of Oracle, and there are some other databases, they will not start if that happens. So it's better, if you're going to do database backups, it's better that you use the database backup process within the database itself so that it freezes the database, performs its backup, and then use ZFS to back up the file created by the database backup rather than backing up the database directly. Now, you certainly can back up databases directly, but you have to shut them down. In a server environment, that would be an outage, right? I mean, I would just do the backup within the database, and then it'll momentarily freeze and then perform the backup, and then I would copy the backup file that it created. But snapshots can be used to roll back the file system to a known state and time. So let's say that you're doing some development, or maybe you're testing some new applications. You install a bunch of stuff, and you work on it for a while, and then you decide that's not really what that application isn't really what you want. So if you had taken a snapshot before you did all that work, and then ZFS was controlling your file system, you could roll it back to a point before the install. Same with data. If you're testing an application and you're writing data out to the file system, and maybe the application has a bug and it's not writing the data correctly, you can restore the file system to a known state. Simple as that. Clones. Whereas snapshots are read-only, clones are read-write. But there's some caveats with clones. So they are a read-write snapshot. You can think of them, I don't know if that's really the correct way to look at them, because the ZFS clones require a snapshot in order to clone the file system underneath of it. But then it allows you to continually to write on that systems. But they initially won't take any additional space until there are changes to the underlying ZFS data sets upon which the snapshot is based. So you can think of the clone as the child of the snapshot. And so the snapshot that created the clone can't be destroyed as long as that clone exists. Clones can be promoted. That is, I can kind of reverse the file system. So I can promote a clone to become the file system. It's the original file system. And that makes it possible to destroy the file system upon which the snapshot was based, and then have the clone become the file system itself. So, yeah, their clones are really not. I mean, if you're looking at this from the standpoint of a virtual memory machine, we use clones to create copies of a virtual machine that we have already set up. But in ZFS, clones aren't really meant to be permanent. They're meant for testing. They're meant to come up, do some testing on the system, do some read writes, and then they're destroyed. They're not meant to stay around. And the problem that you run into with clones is that you have a snapshot which is read only upon which it's based, and then the ZFS clone starts to diverge over time from this snapshot. And that becomes a problem later on down the line when you're trying to manage the clone itself, because it's so far apart from the snapshot that it gets unwieldy, and you'll start seeing problems with the differences in those files. So my advice is, if you're going to use clones, use them for testing, use them for one-off kind of things, but they're meant to be transient. That similar to Docker, you bring it up, you do some testing, you blow it away. That's the way I would look at it. If there are other ways to create permanent file stores. The other thing for it is if you're using it on your boot and root file systems, it allows you to do a quick recovery if the upgrade that you're trying to do fails. So let's say that I was going from let's say, I don't know, maybe I'm on Ubuntu server. Let's take it from 1910, okay, where we first had the ZFS as a file system. So let's say that I'm on 1910 and I start to do the upgrade to 2004, and I have a ZFS pool that I have created a clone on in order to start that upgrade. If for some reason that upgrade were to fail, I could then restore the state of the system back to the 1910 system. So, yeah, or if the upgrade is successful, I can then promote the clone to become the file system and then start using 2004 as the baseline file system. So that's kind of some of the things. I'm probably not going to get into that too much today. That'll probably be the fourth video, because that's really getting into the more complicated portions of ZFS. And we'll probably be here for hours and talking about this. But they're also useful for creating clones of virtual machines. And again, I'm going to caution you that if you do that, then use it for testing. Don't use it permanently. The virtual machine manager is a much better way of doing clones than ZFS does. It's not that clones are bad. It's just that's not what they're not meant for to be around for a long time. Yeah. So enough about that. They're really meant to be a short-term thing. ZFS replication is based on the snapshot. Now, There's a lot of people that use rsync to back up their systems today, and I can tell you from experience, the ZFS replication is so much faster than rsync, it's not even funny. The problem with rsync is, and rsync will work, you can certainly do that. I mean, you can certainly rsync your your data sets, and that's fine, they'll work. But rsync works in this manner. Rsync, if let's say you're copying a 10 terabyte data set. rsync has to look at every file that's on that 10 terabyte data set and then compare it to the target of the rsync to see what has changed. So it's basically going down through your file tree going, oh, did this change? Yes, copy it. Did this change? No, skip it. And it just keeps going down the chain and down the chain. Because ZFS knows what's written, it doesn't waste any time with that. ZFS will immediately start copying through the replication process only the things that have changed. It doesn't need to figure it out. It's already done that. So by the time ZFS, by the time rsync has figured out what files need to be copied, ZFS replication is done. and that doesn't, and ZFS and rsync hasn't even started the process of copying yet. But ZFS replication is based off of a snapshot. So you would do these things, and we'll kind of go through that a little bit today. I mean, replication, like I said, is a very complex topic. I would recommend that you go read the book that I put in the notes. There's two of them. I think actually there's three, but there's two books that you should really look at, and the replication part is actually in the advanced book. To get a feel for all the different permutations that you could possibly want to use with replication. But it's meant to, I mean, you can do all kinds of different kinds of backups. You can do differential backups, you can do incremental backups, you can do full backups. You can back up to tape, you can back up to the file system. You can back up to another ZFS pool. You can back up to a ZFS pool on a remote machine. I mean, the possibilities are endless. And again, if I just covered that topic by itself, we'd be here for 2 hours. So I can't really do that topic justice. So I will give you kind of a sample, and I'm going to let you go explore that on your own. In the book. You can also create continuous copies. So if you want to have replication synchronize two databases or two different systems and keep them in sync, fine, it'll work for that. And then the serialization feature allows me to dump the stream data to standard output and push it into any standard backup. Again, that is out of scope for today. That is such an advanced topic. I don't really want to go there right today, but look for that in the future. So DAC. What is DAC? What is the DAC model? DAC is discretionary access control. That is the model of security that we're probably all used to in Linux because it came from Unix. It is the original security model for Unix, and Linux did inherit that. But DAC, when you get into many users and complex organizational structures, is somewhat limited because it really only has three things that you can modify. It has user permissions, so on a file or a directory, it can give it a username as to who is the owner of that directory. That's typically the way we look at it. And that owner can then have certain privileges, whether it be read or write or execute or all three. Then I can assign also, in addition to the user, I can assign a group, which allows a group of people to have permissions. And again, those can be read or write or execute or all three or one or two of those. Then finally, everyone else, or world, the world permissions, which is if you're not a member of if you're not the user and you're not a member of the group, what permissions do you get to the directory or to the file? DAC works okay for simple things, but it doesn't work when you have complex organizations. Take this one, for example. Let's say I have a development team, and I have a number of developers that are working on the code. They're writing the code. And then I have a project manager, which is managing the project, keeping track of the the project software, the project management software, to see how we're doing as far as time and budget and all that kind of stuff. And then maybe I have testers that don't need access to the source code, but they need to be able to get access to the executables and be able to manage it. And then maybe I've got the user department, and the user department wants to know what the progress of their, what are they paying for? What are you guys doing? How far are you along with it? And show me the results. So each of those groups has different needs. Even though they might be working in the same directory pool, DAC can't handle that. I can't have a project manager which has access to the project management team and maybe the notes that are coming in from the developers as to what the status is of their unit test, or for the project lead to be able to look at the stats from the testers to see how much of the integration has been done. And then finally, the user you don't want them being able to modify the code. You'll want them to have maybe no access to the code at all, the source code, but you want to let them have access to all the project notes as to what's going on and the team statuses. So DAC just doesn't handle the complex situations like that. It's not possible to really set that up without creating multiple directories and linking them together or having things. You're basically going to end up in a duplication of data situation if you're trying to use DAC to manage something like that. So POSIX brought with it the access control list. And access control lists are not enabled by default, oddly enough, in Ubuntu Linux. Nor are they enabled by default in ZFS, but you can turn them on. You can install the packages to use it. Access list is you can, just like it says, I can create a list of permissions, and it can be by people, and it can be a whole list of people, and I can grant them certain permissions to certain directories or files. It's very fine grained. It also has a group component, so I can have one to many groups with different permission levels set on the directories and the files. And of course, it has world writable as well. So yeah, you can have this whole list of every user, and you can be very specific that if I'm the project lead, then I would have access to looking at the status notes from the developers, the test results, the project management software, and I would be able to look at any budgetary information maybe that was being tracked about the project, so I would know how much money I had left. If I was a developer, I would have enough access to be able to run tests, build code, sequence it out to a build at night or hourly, however you're doing your builds. And then finally, the testers would have a set of accesses that were unique to them as well. But you can list all those. So ACL promotes least privilege, and least privilege is a security construct, which means that I only grant the user the absolute minimum amount of permissions that they need in order to complete their job. The problem with DAC is that typically what happens is we have to open things up more broadly, and you have unintentional results. In order for it to work, you have to provide additional security permissions to users that shouldn't have it, simply because you don't have any other way of dealing with it. But whereas ACL allows me to get very specific. You can control everything, the permissions, the groups, and everything on the same file. So ACLs are one of the problems with ZFS. They don't work the same between BSD and Linux, however. So if you are importing BSD ZFS pools into Linux, you may find that your ACLs that were on BSD disappear because Linux may not understand it. Yeah, I know. There is a huge effort that is underway by the OpenZFS team to try to converge these two all the platforms together into a ubiquitous OpenZFS. And as with anything, when you have many teams working on things, you get divergence in the code space and differences in how people develop things. So that has been one of the issues with it. ZFS ACLs on Linux are the same as ACL on ZFS. So you only need to learn this once. Once you've learned the ACLs for Linux, or once you've learned the ACLs for ZFS, they work exactly the same, so you only need to learn it one time. So what do we need to do to prepare to use ACLs? Well, I need to install the ACL package from Ubuntu 2004 server, which is what we'll be using today. And you do that with a apt install ACL. You also need to enable the option in the ZFS pool or the ZFS dataset, wherever you're going to provide it. And just remember, back when we talked before, that any options you set cascade down. So yeah, there is a option called ACL type, and you'll want to set that to POSIX ACL for the ZFS pool or the ZFS dataset. It is not enabled by default, so if you want to use ACLs, you have to turn them on. You can setting ACLs is done through the set FACL and get FACL commands, and we'll talk about those. You can have as many, like I said, you can have as many set FACLs as you need in order to set the permissions exactly the way you want them. You can even create a list of FACLs for a project, so that if you're creating new data sets and creating new areas in the system that need to have that same set of permissions, you can then just rinse and repeat from an access control list file. Yeah, you can have as many as you want, as you need in order to accomplish whatever it is you need. Typically what I do, if I am setting up ACLs, and I haven't done this for a while, I don't need this for home use, but for enterprise use, definitely. What I typically do is write up a matrix. Take a spreadsheet, list out all the permissions that each of the types of users need, and then put the data set next to it, and then if it's a table between the users or the groups at the top and what access levels they need. And then I usually create an ACL file in order to map what that spreadsheet says into an actual ACL list for the file system. And then I just run the get FACL with the list, and I'm done. That's typically how I do it. So I guess probably the thing to do here is to get into a demo. And I'm going to go full screen again. So let me do that. I am going to be using Virt Manager today because of I can't do this on hardware. I only have one machine that has enough hard drives to actually set up this demo, and it's kind of in use. So I'm going to do this on a virtual machine. So I want to show you. Let's open that up. I'll show you kind of what I did here. So you can add drives to virtual machine. It's done down here with add hardware. But before you do that, let me just close this up for a second. Let's create a new one, and I'll walk you through the steps you do for Virtual Manager. So when you're up here with your ISO and you're looking to map which drive you want to use for your install, so I will come down here. We'll go ahead and do this part first. You've seen this before, I'm sure. I want to cover this because it is a very powerful feature of Virtual Manager. If I could find Ubuntu 2004 live server, there it is. The other thing, okay, so we've done that. I want to come back in here. You'll notice I have created some pools. So you'll need, if you want to create more than one drive in Virt Manager, or you want to move that drive to a different location maybe you have a larger hard drive that you want to store your VMs on, you can certainly do that. And I'm going to create a pool too, but down here is where you actually set it up. So let's say I want to go to other locations, and I want to go to my computer. I have some, I think, out here. There's one there, there's one there. So I can then, if I have ownership to this, I don't think I do. No. So I'll have to go create that directory. So let me go do that. I don't own the directory, so I have to do it this way first. Yeah, I could change that, I guess. And then change owner. Okay, so now I should be able to select it. And we'll just open it. And that gives me a place where I can actually store the information that I have. What happened to it? Where'd it go? Did I not save it? I guess I didn't. All right, we'll try it again. Won't be the first time that's happened. All right, open that. Finish. Okay, this time it created it. It's right there. And I can then create volumes. So how do I do that? Well, all I need to do is give it the name. So let's say this is going to be, we'll do something really original here. We'll make this 25 gig. This is going to be the drive I want to boot from. And I can just keep creating storage volumes here. So I can go ahead and create some 10 gig files that I'm going to need for the ZFS pool. So we'll say, oh, I don't know, Z1, and I'm going to make this 10 gig. I only need 3 of these for today, so. Okay. So now I've got all my stuff set up. Now that's the one I really want to use to install on is volume 1. So I'll pick that. And choose an ISO. Yeah, I don't want that. I want download. So I need to go, sorry about that. I told you wrong. I was a step ahead. I do need to do that, but I do have my other stuff created, so I'm all set here. This is correct. And I'm going to give this 8192. Two CPUs is fine. ZFS doesn't require a whole bunch. And then I want to select or manage a custom storage, and I'll go to my pool 2 here, and I'm going to select that. So now it knows to install it on the hard drive over there. And it comes up. Now I haven't done anything yet with the other drives. What I should have done here was I should have selected, well, I got some more configuration to do, so I'm going to go ahead and force this off for right now because I'm not done with it yet. So that's the one I was just working on. We'll open it. We'll go to the virtual machine. Now what I want to do down here, you'll notice that I just have that one, and there's my pool name, but I need to add additional hardware to this. So what I'm going to do is I'm going to select or manage, and I'm going to go to pool 2, and I'm going to select ZF1, Z1. Finish. And it should have added it right there. Z1. And I need to add the next one. So select, manage, select Z2. Finish. Add hardware. Not too difficult, right? Okay. So I've got all my stuff. There's Z1, Z2, Z3. I'm all good there. So at this point, I can go back to my display and start this up. I guess I should go tell it which bootable device I'm using. do. Oh, I see. I see what's happened here. It has automatically removed it, so let's I want that one. apply it. And then go here. And I need to stop this. I better check this because it may punt the drive out of there again. So let's just see. Nope, it didn't. All right. Well, it looks like it did punt it. Hang on. All right, so I had to come into the boot options and change this back. So that is now done, and we'll apply that. Hopefully this time it should start up. Oh yeah, much better. If I had said I was going to do my changes first, I wouldn't have run into this problem, but since I did, I'll just show you how to solve it. This is coming up into the live environment. Okay. Yep, that's fine. We'll upgrade to the new monitor. I don't understand why I'm not seeing. Oh, there we go. Don't need any of that. Don't need any of that. Yep, it's got the right drive. It shows me that it found the other three drives. So that's done, and we'll continue. We'll install that. Don't need that, and we'll just let this run. I'll be back when this is completed. It won't take too long. Okay, it's done, and I will go ahead and reboot this thing. And let's see. All right, so I want to get out of that. And go into the settings. Actually, I think this will work. Nope. It's going to reboot off of the CD-ROM again. Yep. So let me just shut this down. We'll go to my boot options, we'll unselect that, and we'll go to my first disk. And we'll start her up. That looks better. The first time you bring up the Ubuntu server, you will have to wait for it to create all the keys, do all of its necessary cloud stuff that it does, and then wait for all the mounts to complete. It does install a snap for LXD. I think there's one other. LXD, I think, is also installed with this as well, of course. But I think those are the only two snaps that it actually pushes out here. I'll watch it. But you can see it's setting up the cloud config and the SSH keys, and that should be done. I know this is too small to read, so bear with me. What I'm going to do is go get the IP address, and then I'll switch into the an SSH session in order to actually do anything with this, so you can actually read along. So it looks like I'm at 122.199. Okay. So I'm going to go ahead and minimize that, and we'll come over here. I think that was it. Yep. Hopefully that's a little easier for you to read. If not, I can make this a little bit bigger. Let me just move that over here so you can see what I'm doing. All right, so at this point, we would do our normal dance to make sure that the system is up to date before we start any actual installs of any software. And it looks like it's doing NetPlan. Looks like it's got Python updates, strace. Okay. So what I need to do here is search for ZFS. So just like before, this is the one we want, and Ubuntu is 0.8.3. The latest version that I could find out on the OpenZFS site is 0.8.4.4. There is a ZFS 2.0. I don't know what happened to 1.0, but I know that 2.0 is still in work, so I'm not going to install that one. We'll stick with the 0.8.3. It's close enough for what I need today. So we're going to do that. And the other thing I'll need is well, here, let's do a search. Just to make sure I get it. Now, it's probably so many things that have ACL in it. It may have scrolled off, and I may have to actually pipe this to more. Nope, it's there. So ACL and ACL2. I want ACL. I don't think I've ever used the list binary one, so this brings in the get facle and set facle commands. Okay, and then I'm going to reboot just to make sure I don't have any services that, that are needed to be restarted before it comes back up. And then I can watch on the console window what's happening with the machine. Okay, got that done. So I'll go ahead and go back in. Okay. The other things I might want, my usual. Lots of stuff. I'll be back. It'll take a minute. Okay. That's all done. So I should be able to run HTOP. Let's just see how much memory it's consuming. 221 meg, not a lot. Let's look at glances and see how much processor overhead is running. Not much. 514 meg of memory. I do want to go into root directly, yes, in order to do these commands. So I should have zpool, and I should have ZFS. Just typing them in gives you your help, of course, just like any other. Okay, I always do that. All right, no pools. List, not status. There we go. No data sets. So the first thing I want to do is I want to see if do I have my drives? Are they here? So there's B, C, and D. Okay. So I have 3 virtual drives, I have enough. That's enough drives to actually build a RAID Z or a RAID, or a RAID Z1. So let's start with that. I will give this the name ZPool, and I'm going to say RAID Z is the type. Then I'll just start listing the drives. Which are the ones that are listed there. This will take a few seconds, I should say. All right, so we should. There we go. So I now have that done. So there's a couple of things that, like we've said before, this actually mounts it to your file system. If I do a ZFS create, let's get a couple of them here. Let's do code. Let's do source. Let's see. Let's do test. Let's do project management. And then let's do sales. Okay. So I've got all that stuff in there. I also want to create a home directory for me. All right, so I think I've got enough stuff here. And my mounts are all set up. I can do ZFS list. One of the things I didn't show you last time was that how do you find out how your system is performing? Well, as it turns out, there's an IOStat command that's available for the pool. And you can say verbose, and then how often do you want it to sample the file system? So it'll start running. And as you can see, it's looking at the pool itself and the drive. So this is going to be watching the drives as they actually do stuff. So I'm going to leave that running. And I'll create another window. Oops, I think that might be too much. All right, so let's see. I think do I have it? Nope. All right, so I'm going to go out here to ZFS pool. DJ. I'm going to give me ownership. Now I'm using DAC to do this, right? All right, so now I own it. I'm also going to change the permissions on this. I should be able to just change mod. I'm going to make it 750. Okay, so that's discretionary access controls, right? So I'm setting the user mode for the directory to read, write, execute. I'm giving the group permission, which is me, read, execute. Now, I could open that up and allow other people access to this. I could add another group if I wanted to, and then world writable and world readable it's off. No one can do that. So I should be able to go in here. I'm going to create a script. I need some test data. Let's see. Let's do a DD. Block size equals 1 meg. Count equals 3. Oh, I forgot to use the output file. All right, we'll fix that. You saw that, didn't you? Okay, so now I've got some test data in here. I can look at this. This will tell me how much. I mean, I can put it in human readable format too. So yeah, it'll tell me how much data I actually have in there. So it's about 9.2 meg. If I do that, which is about right. And so I think the last time I did this, I actually had 4 files, right? Okay. Now I have 4 files, and that should be good enough for a test for today. So what I'm going to do is I'm going to set up my fackles. So let's go back up here and let's actually look at this and see what it actually showed me. You can see that there's some activity going on here, but yeah, it's not much. Now, of course, I'm not going to get any bandwidth gains from putting multiple drives on this because they're all on the same physical volume. But I mean, for today, this is fine. I mean, I just don't have the hardware resources to be able to do this. So first thing I want to do is let me get out here, and I'll leave this one behind for a moment, and we'll drop back over here. So the first thing I want to do is a ZFS list, just to see how how things are shaping up. So yeah, the rest of them have just a minimal amount, and then DJ Ware has 12 meg, of course. And I can do, let's see, list all. I think that's right. Is that right? Yeah, type all, which if I had any clones or any snapshots, it would show that. You can also do, if you had snapshots by itself, you could do that. So I don't have any. So let's set up, and I want to do it on ZFS pool, and I want it on DJ Ware, and I'm going to say, well, we'll just call it, let's call it, since today is Tuesday. All right, so I've created a snapshot, and there it is. Doesn't have anything in it, but it refers to 12 meg. So let's say that we want to create a clone of that. So ZFS clone, and you would take the pool name, the data set name, and the snapshot name. Okay, so now I've created one. So let's see, there's my snapshot. I can also do I think clone. Well, nope, I guess I'll have to do all. So clone is actually showing up down here, and just like always, the Linux anomaly, it has mounted it. So my clone is in there. So if I go in, here, let's do it over here. Let's see what my permissions are. It should be owned by me, and it is. Okay, so there's my files. So let's go to make data. Now, I don't want to disturb those other files because if I overwrite them, then they become a part of this clone. So all right, so no, I didn't get it. Oh, because it wrote it into the base file system. So yeah, let me fix that. Okay, so what I've done here is I have created this, which allows me to write just 3 files into that directory, and that is what I have run. And my base file system only has the 4. Because I'm running under a snapshot and I have not done anything with this. So my snapshot, which is Tuesday, will have just the file 1 through 4, but this one, this clone, has everything on it. So I need, if I were to destroy this clone, then all of this would disappear. My make data 2 would disappear. My files 5, 6, and 7 would disappear because they're not protected by a snapshot. So let's take another one. Let's take another snapshot here. And we'll do today. All right, so now I've got this snapshot, plus the other one has 12 meg in it that's used. That should include what's in the clone, right? That's how that should work. That should include what's in the clone. Even though I haven't done anything with it yet, it should be in there. So we hope. So let's try something here. So I want to, let's say I want to destroy, let's say that I do a ZFS destroy, and I want to destroy ZFS pool DJ Ware at Tuesday. That's the one that the clone was based off of. It will say, oh, no, you can't do that, because if you do, and I need to be out of that directory, if you do destroy this, then you can't, because you have a clone. So I couldn't give it a -R, which would then destroy the data set, DJ Ware clone, and then roll it back would destroy this as well. So let's destroy. Okay, so that's gone. You can look at my pool here. It's all back. So if I go to, you'll notice that all that new data that was saved in the clone is gone. And there's no, I mean, it is gone. Unless I had a backup of it, there's no way to get it back. So I can then, if I want, I can then destroy that snapshot. And I'll go ahead and destroy the one for today as well. Okay, so I shouldn't have any left. No snapshots available. All right, so don't have any available. So I'm going to create another pool. And I'm going to do a backup pool. I'm going to make it a RAID Z just like the other one was. Oh, I don't have any drives for this, do I? No, I don't. All right, so let's shut this down and we'll add some. I'll leave that one up. Okay, this should be off, and we'll go in here, and we'll go here. So I need to create 3 more drives in order for this to work. So I'm going to add some more hardware. And we'll call this BK1, just so we know what is what here. And we'll make it identical. BK2. And we'll make BK3. Okay, so all good. And I need to close this now. And those hopefully have shown up in here. Not yet. Choose volume, finish. Add hardware. Okay, so now I have 6 drives. So now I'll go ahead and bring that back up. And we'll go to the window, so we can status window, so we can see what the console is doing. All right, Z pool list. Sorry, status. Okay, so I have those. So now what I want to do is I want to do a Z pool create backup pool. And before I do that, though, I should probably check to see if the machine is seeing these. E, F, and G. Yep. Okay. And we'll want to make, then we have the name. We want to call this, we want to make this a type RAID Z. And we want BDE, BDF, BDG. All right. So now I have 2 pools online. Both are RAID Z1. So I can then do, let's say, I want a, first of all, let's get them all. So as you can see, I have just the pool itself, and then in Z pool, I have all of those. So what I'm going to do is I'm going to do a ZFS snapshot, ZFS pool. I'm going to create one for today. And I have 12 meg in, oops. Oh, ZFS pool. There. That'll probably work a lot better. Okay. So at this point, what I want to do is I want to send this data set as a backup to the backup pool. So we're going to do ZFS, and this would be the first time, right, that it's not going to do an incremental. This is going to do everything in that pool. So I have to give it the snapshot name. I'm going to pipe it to ZFS receive. So this is just a stream of data. So that pipe can be ZFS. It could also be, you could push this out to a file. You could push it to a tape drive, whatever you wanted to do with it. This can also be pipe it into SSH and then send this over to a ZFS pool on a foreign machine. And then we're going to call this backup. Oh, how about, let's make this DJ Ware BK. How's that? All right, so what do we got now? So you'll notice that I have it also copied over the snapshot as well as the file, and that contains 12 meg. So if I were to go to backup pool, okay, there's my data, there's the script, exact duplicate of what I just did. So if I go, let's just make another 12 meg here. Okay, so there's some additional files only. Those are owned by root, so I want to change those to me. All right, so we're all done there. Now, as far as the snapshot is concerned, it's done, right? So the snapshot knows that that's completely done. But what if I want to be able to send over an incremental pool to that? So if you look at, well, let's do ZFS by itself, and we'll look for the send command. You'll see that it has a number of options here. Bookmarks is something else, but we can talk about that. So there's it's sending snapshot to snapshot, snapshot to file system, and we can do a man ZFS, and we can get a little bit more detail about the send. So in order to do that, I got to go all the way down here, because what I want to do is I want to be able to send this over as an incremental, but I don't want to wipe out the backup I just did, because if I wipe out the backup I just did, all I'm going to do is I'm going to end up copying over just the delta, right? Because I'm going to create a new snapshot. I'm going to copy over just the delta, but I'm going to lose the main backup that I just sent. So yeah. So what I'm going to do is, now I've already done this command, I just wanted to make sure it was going to work. So I'm going to send, now this will send all of the pools to the system. So this would be a full backup again. So this is sending both Tuesday, and it also is going to send the snapshot for today. So it's going to do both of those, and it's going to send those over to a new data set called DJ Ware Tuesday. So as you can see that it has, this was the first one I did was 12, and then I added additional files, 4 more. And so now I have a total of 24 meg that's stored over there. So I'm not going to run that command, but I can go over here. Now, if you delete, if you drop any of these, if you destroy any of these, they will tell you that there are children involved and that you would have to do the -R to destroy them, as it said here. So, yeah. So it's if you can do the -R, which says I want all of them done, or you can leave the R off, which says just send over the incremental change from Tuesday. And in that case, it would just push an additional set of files over. But I can go to the backup pool. Okay, and we should see all of the files there. But if I go into this one, it's only going to show me the first 4. So that, I mean, that would be doing a differential backup, right? Because you are actually copying, you're doing a full backup each time, and you're collecting more and more data, which is what a differential backup does. So what else do I want to show you? I guess we should dig into the ACLs a little bit. So let's back out of here. Let me yeah. So let me do zpool destroy on backup pool. Oh no, I'm gonna the pool. There we go. Now everything over there is gone. So as far as what's going on here is concerned, what I need to do next is to work on some ACL. So the first thing we want to do is we want to look at what is our setting. So we're going to do a get on ACL type for ZFS pool DJ Ware. And you can see that the default is off. So I need to set that, I need to turn that on. Forgot about that. Yep, needed to set it that way. So now when I do my get on it, I should get POSIX. Okay, so now as far as ZFS is concerned, POSIX is enabled. So let's see how this might work. Now I've only set it on DJ Ware, so that's the only place that I can actually use it. So let's go to let me open a window, and so I'm not doing this as root. Okay. Let's go over here. And let's see what we have first on these files. So this is the DAC list. So I've got read write, and then, well, it's inconsistent, isn't it? So I want to, let's change this first. I probably want to take execute off of the files. So I probably actually want to make that 640 file. Yeah, there we go. So yeah, so that I actually just have read and then for the group and then nothing for anybody else. And yeah, you don't want to make your files executable. That would be really confusing. So I've got that. So let's make a directory here. Let's make let's say this is my source code. And we'll make another directory, and we'll call it my build. And maybe I'll make another one for documentation. All right. So as far as the system is concerned, let's go build. Let's go to CD build, and I will create some doc1. Source. And then in my build, okay, so just give me some things to work with here. So the first thing I want to do is let's do a get facal. And I can have that tree down. So let's do -R. Okay. So this is what it looks like. It's kind of a table, and it goes through and it says, okay, currently this is what you have. You have on build, now it treats everything as a file, which is what Linux does too, and Unix did as well. So you have read, write, execute for the user, group read, write, execute, and then read, write for other. Make is read, write, and then read, and then all of this down here. So yeah, so I can do all of that stuff. So what if I want to, set, let's see what we got here. Let's say that I want to set a facal, and I'm going to modify -M. -X will remove permissions, -M adds permissions. So I'm going to add a group, and I'm going to make it wheel, and I'm going to give that read execute on ZFS pool, DJ Ware, and I'm going to do it on build. Because this would be, yeah, other people are going to need access to that directory, right? So I'm giving wheel access to that near character 3. Did it boo-boo? Do I have a wheel account? That would be even more important. Probably not, because I'm not on Fedora. Well, okay, we'll make a group. All right. Okay, this time it worked. So now if I do a get facal on build, you'll notice that now wheel has been added to the list. So I can just keep doing that. I can just keep granting permissions all the way down and adding users, adding other groups, and so forth. So yeah, and that is a really nice feature. I mean, I could be really discreet, and I could grant specific users to specific people. I could do this more intelligently, which would be to add, those people to a group and then manage it from the group level. So that would be better, because it would take a lot less work for the admins to keep up with. Plus, they would know these people are members of this group, and if there were new people coming on or leaving, they would just know to remove or add people to that group list. And then the permissions would automatically be granted to the file system. Much easier to do it that way. So let me kind of go back in here for a moment. I'm certainly not done with this topic. I mean, ZFS has so many different wrinkles and so many different ways of doing things that, they're like I said, cloning, I wouldn't use it the same way I use cloning in a VM. It's not permanent. If you make it permanent, you're asking for trouble. I'm telling you that from personal experience. You will get yourself sideways with the file system, because the snapshot upon which it's built is read-only. The clone is not. It's read-write, and you will gradually diverge, and that will get you into all kinds of trouble. Plus, the fact is, if there's no way to preserve the clone unless you revert it to take over the file system. So it's really meant for testing, and that's the way. I mean, if you feel differently about it, let me know in a comment below. I mean, this is kind of my take from using it. I mean, I have never read that, oh, do you just use this for testing? I've never read that. But there are specific use cases for clone, and there are specific times when you just want to copy the files over to a new data set, and then remove them from the old if you want to do it that way. I mean, so the old-fashioned ways still work, right? I mean, ZFS doesn't get in your way, but it does provide a whole new set of capabilities. And the next time we talk about this topic, we'll go into the more powerful aspects of ZFS, and that is, once you've got it built, how do you share it out? How do you allocate things like ZVols? The ZVol is a ZFS volume. You also have CP. Yeah, you have the ZFS POSIX file system. So yeah, I mean, there's all different ways of being able to cut this thing and slice it up and dice it any way you want. That's really the beauty of ZFS, is that it's flexible. It's modern. You're away from this nonsense that we've carried around for 20 years with having data volumes and trying to manage volumes and all this nonsense. That ZFS does away with all that. And so I hope you enjoyed today's video, and if you did, please like and subscribe. Let me know in the comments below what direction you think it should take after this. I know sharing what I've got to do. I got to do Samba. I've got to do NFS, and by gosh, I'm going to do iSCSI too, because iSCSI is how you expose ZFS to VM machines, and so that you can create pools for them to use. Hope to see you all again real soon, and bye for now. Stay safe.